Hi, my name is Len. Currently, I'm enrolled in the SCADA development course, and my teammates and I pursue an engineering independent study in which we tried to develop a communication solution to help engineering students upgrade their engineering products to the IoT level. Our aim is really ambitious, and we know it, and we try our best to make it matching our capability. So the final deliverable of the, the independent study includes the implementation of a model demo. I am in charge of preparing the hardware system for this model demo, and this video will be about me conducting a unit test to prove the working of the hardware system that I prepared. There will be a lot of technical terms and technical knowledge that you should be known of before you listen to this unit test video. So if you are confused about any terms of technical knowledge, you can refer to the background information section in my individual report. And for now, we'll focus on the unit test. So for this unit test, we will conduct it totally on simulated environment, like on TXbox3, which is an engineering tool to program PLC, and GT Design tool, which is the software to prepare the interface for the HMI. And because we do not work directly with all the physical devices here, so we will need to fetch some data in order to go through all of the steps in the operation chart. The data that we shall be fetch is the value of SD6301, which is the built-in analog input of PLC FX5U, and we will try to speed up the counter C0 and C100, which is the counter for the duration of vegetation. That's an overview of the unit test that we will be conducting. Let's jump in and do have a closer look on how the system works. If you read the report, you will notice that in order to an industrial processing unit like PLC FX5U to exchange data with the interface or other database management system or software management system, it will require a bridge to transfer the data, and that bridge is called OPC, Open Platform Communication, and Mitsubishi has specifically built an OPC library for the PLC, for their PLC processing units, which is the MX component. And so in this hardware systems preparation, I take advantage of the C# library in the MX component to create an interface on Windows Phone in Visual Studio. With this interface, I can directly transmit commands like change the value of the device point, like the C100 or SD6301, or I can read the state of that device point on the interface. Like if I want to know whether the M1 is on or off, I can read it on the interface. So let's try it. Before we can implement the MX components library, we need to set the logical station number for the destination we want the interface to communicate with. So we have the communication setup utility, which is the software going with the installation of MX component. One we need to set up this one once before set the logical station number as 1. And if you connect your computer directly with the PLC, you use the physical COM port. But for now, we will use the set it as the GX simulator 3 as the destination. CPU type that we want to simulate is FX5U. That's it, finish. We try to run the GX simulator 3. Right, so my program has been running successfully. Now we will try to adjust the vector data of the analog bearing channel. Type 1 connect. It shows that the connections, like the interface, has successfully connected with the simulated PLC. We type in the address 301. The value you can put any value you want. 15 right there. This is meant to be the sensors, the data of the ambient light sensor to measure the light intensity, which is in the lighting area. Alright. So let's follow the operation chart for the lighting system. After we pressing the power hold button and HMI switch on, we have to input the parameters manually on the interface. So these buttons are physical buttons. They are electrical buttons on the system. As we press the power supply hold button and the 5 voltage button, the system will be on and switch the HMI on to complete the starting steps. And we will run the simulation of the simulated interface. Simulator 3. With this interface, it will save you a lot of time, since you will not need to spend time on setting up all the electrical devices on the wiring, which might cost you a lot of time in order to do simple unit test with the controller system. So we turn the roller system on. There will be 4 rollers for one blanking shelf. Turn it on. We need to input the parameter first. And normally for a plant to roll, you would need normally for a plant to roll indoor, we need around 14 to 20 hours of lighting time a day. So now we set it as 5 to 9 p.m. The duration of vegetation. In order to connect the unit test simpler, I would take this duration of vegetation is the number of 2 days. Normally it would be 20 to 30 days in order for a plant to complete its vegetative stage. Minimum light intensity level. Now switching interval 1 minute, so that we get a observe the switch in between light 1, light 3, and light 2, light 4 repeatedly. Alright, after we put on the parameters in the parameter setting board, we will turn on the lighting switch of the light system on. See that the nighttime mode indicator is on because as we set the lighting time between 5 AM and 9 PM, we look at what time is it now. Like the program that I wrote, I took the real-time clock hour data, so it indicates that the hour data is now 1 o'clock 1 AM. So that's why we are in the planting system is in the nighttime mode. And when we are in the nighttime mode, all 4 lights will be off. Now we check the system into the daytime mode by changing the parameter setting. Changing to the start time to be 0. We see that the daytime mode is on, and light 1 and 3 is on. After 1 minute, light 2 and 4 will be on, and light 1 and 3 will be off. So the light sensor's data will be compared with the minimum lighting level that we set in the parameter setting. If it is below the minimum lighting level, all 4 lights will be on to ensure the amount of light intensity on the planting area. It should your sensor's data must be larger than 0, since like if the sensor is off, it will be 0, and if you check the system to believing that the sensor is still operating, is still working, but it sent back to the PLC the 0 signal. And for now we can see that after 1 minute, light 1 and 3 are off, and light 2 and 4 are on. Now we test another feature of the system, which is the vegetative base counter. So this counter will play an important role in deciding when the system will stop, to move to deciding when the system is off, to move to the harvesting process. So I will check the system to speed up the system. So for C100, we make it 1 because we have only 2 days of vegetation. 1. So that you see that it's changed to 1. And C0, looking at my input and output parameters, I have this table in the individual report as well. Looking at this one, you see that the C0 used 14 for hour counting. The C0 to 7, 8, 8. You see that the C0 now owns a value of 718, and if the SM8014, the 2 minutes trigger special register is on, will trigger the C0 to be on. Now we have it on, and the vegetative plate counter is on now. It's 2 now. This is the symbol of normal closed relay. So normally this contact point will be closed and when the C100 is on, it will be normal open, which means that this line will be short, and there will be no signal to trigger the M100, the operating conditions. So according to the operation chart, as the vegetative days counter reach, when it's on, all 4 lines will be off. You will see that whether it is off on the interface or not. They're on off on the interface or not. Yeah. So now they're on off, and it will display the vegetation is finished, informing the user that it's time to move to the harvesting process. There will be an announcement box to inform the users. So if you want to continue the vegetative stage, you just need to reset the vegetative days counter, and input the number of vegetative day remaining that you want, the remaining vegetative day that you want to continue, or else we will turn off the system and move to the harvesting phase. So that's all of the features that I want to show you in my preparation for the hardware system. So for this one, the software team will look at my documentation to develop and upgrade the system to the database management and web application by looking at the device points that I have listed here. Alright, that's all. If you have any confusion, please look at the individual report that I have prepared with all of the technical knowledge and programming explanation, operation chart explanation in more details. So thank you so much for listening.